Okay, so if a person, when he's age 1, he blew 1 candle. Age 1, 1 candles. Age 2,
It
2
sounds
candles.
like he said H, to be honest.
Age. This is age.
Yeah,
This
I
is
think
the
I think
candle.
Mum told you this, right?
Yes.
Is this the same one Mum told you?
Yeah,
That you told me.
3, etc. So the question is that on which year of his or her birthday he blew
21.
all together 231.
21.
Yeah, 21.
How do you get this 21?
Because basically 1 plus 2 plus 3 from the story of Gauss, which I learned from that math book, you think like if you do 1 plus the last number, add those together and times the amount of number divided by 2.
Yeah,
And then that will keep on adding that. Because basically all the numbers, 1 plus, like if it's up to 10, 1 plus 10 is 11 and 2 plus 9 is 10,
Yeah.
3 plus 8 is 11.
Yeah.
Well, they'll keep on doing it. And since there will be half the amount of pairs, which 10 is 5, so it's 11 times 5, and 11 times 5 is 55. So 1 plus 2 plus 3 up until 10 is 55. And 21.
Okay,
So if it's an odd number, you plus 1 and then you divide it
I
by
see.
2.
Okay, so
And
this
21
question.
And 21 plus 1 is 22 and then divided by 2 is 11. And that's like 21 times 11 is you just split it apart and then add the 2 digits. So,
Okay.
2
So
and
this question is simple, right? 1 plus 2 plus 3 plus here n
I already know
is
that.
231, right? So we want to find out the n, okay? This is a small number, pretty small number. You can try, right? You can try 20 is smaller and you try 21, right? Okay? But if this number is big, it may take a while, right? So the question is, how do we formulate this? So this one, right? We know that, right? This is the sum I equals 1 equal to the n, right? S equals that. And we want to find out this is tier 231. Okay? So in Python, we can just double check sum range start from 1 till 21 plus 1, and that will give us 231. But the question is, how do we find out this? How do you usually find out this? Are you trying? I mean, how do you try?
You just make the first educated guess and then you
Educated
and
guess.
then you kind of like narrow it down
Okay. Okay.
to
Okay.
1.
Yeah. Okay. So this is kind of like a binary search. Okay. Okay. Before I go into the binary search, let's talk about the. If we try the n from smallest to biggest, we try 1, we calculate the accumulated sum. We try 2, the accumulated sum is 1 plus 2. Okay? Until the accumulated sum is equal to the target or is bigger than the target, right? Define Fn. This is the target we are looking for, right? So S equals 0, I equal 1, I equal 0, okay? So while the S is smaller than target, okay, let's put this target, right? Smaller than target. I plus equal 1, right? I incremented by 1 at each iteration. 1, 2, 3. S plus equal I. Okay, so return I if S equal T. Else, let's say minus 1. Okay, so simple, right? Accumulated. Do you understand this? This is brute force. We try n. We try this is the target, right? This is the target. We try the h, which is n. Okay, we try 1, the sum is 1. We try 2, the sum is 1 plus 2. We try 3, the sum is 1 plus 2 plus 3. We accumulate this sum until the sum is equal or bigger. If it's bigger than t, then we don't need to continue, right? Because it's bigger. If we keep adding more numbers, it will be always bigger. Smaller than t, okay? Okay, this is brute force. The educated guess, which is binary search. Okay, so how do we get a binary search? Define Fn Ft. The left equals 1. The right, the upper bound, let's say t. Okay, while the left bound is smaller or equal than the right bound, the middle is L plus R divided by 2, right? Divided by 2. This is the same thing, divided by 2. Okay, so now current sum equal, you know how to get a sum, right? I equal 1 to n, I. This is equals,
Can you
this is equals to what? The last item plus the first item times n. How many items divided by 2? This is the same thing, right? S1 plus 2 plus tier n.
So-
This is S. I will write it again. N plus n minus 1 plus n minus 2 plus 1. And then we add it up together. So 2 times S equals n plus 1. How many times? How many items? N times. Move the S to the other side. Okay? This is the equation to get the sum of the first n natural numbers. Okay? So S equals n times n plus 1 divided by 2. Now we have to check, right? If S equal the target, great, we find it, return M. Okay? Now this is the final research. If the S, look, if our current sum is smaller than target, this is L, this is R, this is middle. Okay, now the sum is here. If the sum is smaller than target, if sum is smaller than target, so where should we
I
put?
think so when you have a number, you get a number. You like 231. I think you could just like times it by 2 and then square it, and then you give you a number which is pretty close, and then you just have to keep the numbers around.
Why? Why you
Because
can?
it's basically the reverse.
Okay, reverse. So what's this? 20.
20 times 20 is 400.
Aha, very good. Yes, yeah, this is a good estimate, right? Okay.
Yeah.
Okay, yeah, good. Coming back to this, if our sum, which is smaller than the target,
I think 21 times 21 is 441.
Visa, $947.52. I thought we used pounds, not dollars.
So look, this is smaller than target, right? Target is somewhere here. So it must be on the second half, right? So we say the left equals the middle plus 1, right? If it's on this side, on the first half, then as R equals middle minus 1, right? Every time we cut in half, we cut the search space in half. This is binary search. Do you still remember? Okay. I have a number in my mind. Between 1 to 100 inclusive.
50.
50 is bigger than the number in my mind.
25.
25 is smaller than the number.
I feel like you're just gonna change it.
No. Okay. 25 is smaller than the number in my mind.
33.
It's smaller.
30.
30 is definitely smaller, right?
26.
No. 33 is...
40.
Yeah. 40 is smaller than the number I...
45.
45 is smaller than the number in my mind.
47.
Yes. Okay? You see? Always cut in half. This is the same thing. If we don't find it and left meet the middle, then we return minus 1. Binary search. Make sense? Binary search. Okay, coming back to this
But I don't
equation.
know when to stop.
Good point. When to stop? The left and right. The left is 1, right? The right is t. Then when the meet in the middle, if we don't find it, then we stop.
Okay.
Why can we use the binary search? Because m increases. If the target, the value increases, right? The sum also increases. It's the monotonous increasing or monotonous decreasing. You learned about the mass function, right? Mass function, yeah? This is n, this is s. The monotonous increasing is that if n increases, s also increases. This is not monotonous increase or decreasing. If this is fx, this is x. If fx equals x squared, this is not monotonous increasing. Why? Look, it goes down and it jumps up, right? This is not monotonous increasing, but this is. We can use the binary search as long as this search domain, in the search domain, the input and the output is monotonous relation, okay? The third approach, right? We know this, right? We know this. So we can just solve this. Solve this, right? Yeah?
Yeah, that's what I said.
Okay, so how can we solve?
You just need to
Equals
you
target.
just need to times 2.
Yeah,
and then,
times 2, right?
and then
Look,
square it and then floor.
look. Times 2, right? Yeah?
Yeah.
Okay? This is quadratic equation. We talk about that. Quadratic equation. What's A? A is this coefficient, A. What's this? B. C is the coefficient. So A equals 1, B equals 1, C equals minus 2t. Right? So ax squared plus bx plus c. This is quadratic because this is 2 here. 2 here, okay? A, B, C are constant, are not changing, unknown. X is unknown. Fx equals that, right? Quadratic function, remember? Quadratic function. It could be like that, it could be like that, right? It's kind of this kind of shape, okay? A, if it's bigger than 0, it's this shape. A is smaller than 0, is this, pointing up. So how do we get the root? There are 2 roots. 2 roots. Maximum 2 roots. Okay? Maximum 2 roots. For example, like that, right? 2 roots. Here 1, here 1, right? Sometimes 1 root. Sometimes 1 root. Sometimes no root. Okay? The intersection between the x-axis. So A, B, C. How can we get calculate the root? There are 2 roots, which is 2a minus b plus minus square root b squared minus 4ac. We can ignore the minus, right? Because look, minus b is positive, minus b is negative, minus some roots which is more negative. We can discard the negative roots. Okay, so which is that 2 times 1 minus b which is minus 1 plus, okay, plus square root of 1 minus 4ac, so plus a times t. Okay, this is the root. 2 minus 1 plus a times t. If we plug in the 231 here, then we can get the answer, right? Okay, so by using the Python function, we just calculate this, x equals that. Okay? Remember, there is another root which is minus. We change this sign to minus, right? But we're not changing it, we're not considering it because this is the positive number x here. So we just have to check if x is an integer, then we return integer x, otherwise return minus 1. O1 constant term and space. Yeah, if the square root, we consider the square root is O1, amortized O1. Okay, so there are 3 approaches. The first one, brute force, we're checking the n from smallest to the biggest. The second one, binary search. Every time we check the half, the middle, right? We check the sum. If it's smaller, we move to the upper bound, upper half, the second half. If it's bigger, if the sum is bigger, we narrow down to the first half. Remember the guessing the number, right? Guessing the number, always guess the middle. Why we can always get the middle?
Because then that's the one with the one that like gets equal sides on each other and the largest number on each side equally. So you always get the same amount of numbers.
Yeah.
If it's smaller or bigger.
Yeah. So we always abandon half.
No, but so.
Yeah.
Yeah, because half is max.
Look, 100 numbers here. You guess the 50. Your number is smaller. Then you just focus on this half. You just abandon this. You don't look at this anymore. So we just get rid of this.
If you don't look at it, it doesn't mean you kind of abandon.
So search space, abandon.
And if you pick 60, it'll be if it's above 60, then that's good. But if it's below 60, then you have more numbers.
Exactly. So you have more numbers. So that's kind of like the worst case, and it'll be take longer than splitting in half.
For example, 1 to 100, right? We know it's from 1 to 100. The first approach, just check 1, 2, 3, 4, 5, 6 until 100. In the worst case, it needs 100 iteration. This is O(n), right? Because it's going from linear from left to the right. But in the worst case, the previous are not answer. The last one is the answer. Okay? Yeah. The second approach, binary search. Each one cut in half. So it's log n, right? Log n at most. Okay? Every time we abandon half. The third approach, O1, because we are solving the equation, mathematical equation. Yeah, mathematical equation. Remember?
Whoa!
This is a quadratic function. There are 2 roots. When you go to high school, right, you learn this more. The polynomial.
It's not called high school.
Okay.
That's in America, you know.
What
Then in UK, what's that?
It's
big school?
A level.
yeah.
Okay. It's high school. Mapping high school roughly. Okay.
No. It's like how in America Okay, I think they call it middle school, but we call it secondary school, right?
Exactly, and they call it elementary school.
Elementary school.
But we call it primary school, right?
Exactly, yeah.
Okay, so what have you learned today?
Nothing.
Why is it called elementary school
What have you learned?
anyway?
Where did we go to learn? Elementary.
Ari, what have you
I
learned?
think it's supposed to
Everyone,
be
what
for
have you
elements.
Ow!
We didn't really learn anything. We were just like talking about stuff we already know.
Yeah.
That's good. That means that's good. That's also a good thing
But we
because
didn't-
we're reviewing,
We
right?
didn't
We're reviewing.
learn nothing.
But at least look, brute force. Okay, so can you explain to me which method is the best? I explained 3
The
methods.
last one.
Why?
Because always brute force takes the most long because you're just checking.
Plus you did the brute force for first.
And then
And I'm
the
pretty
second
sure brute
method,
force is the worst.
the second method, which
The
is
slowest, I guess.
no, second method is better than the first approach because
No.
time research.
Brute force is the
Uh-huh.
slowest.
Okay,
And you said
So-
no.
okay.
You said no. You said no. You
Okay,
said no.
okay,
No, 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 no. You said no.
One
You
question.
said no.
One question.
You said no, 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 no.
Why
No,
did you
no,
go-
no.
If the target is 5601, what's the age? What's the age?
105.
Actually, if answer is 5151, what's the answer?
Wait, don't tell me. 101.
Yes.
Yes!
Yeah, because it's 100, right? 100 is 50 plus 101. Okay.
Yay!
Okay, you got it. Okay.
Oh yay.
Okay, so then, yeah. Come on. The closing part. Come on. When mommy told me this question, I actually I misunderstood.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. 1 with 1 digit you
Yeah,
do
I saw
1,
it.
and 2 digit you do 2.
Okay, so the next lesson, right? Basically, the
You'll
next
do
lesson.
your one.
So the H1 1 candle, H2 H1 1 candle, H2 1 candle, H3 1 candle because 1 candle, 1 digit, right? And 9, which is 1 candle. 10, you need 2 digits, so 2 candles. Okay? And then 99, still 2 candles. 100, 3 candles. Okay? Yeah.
The person is gonna be very old.
Yeah. Okay. We'll talk about that next lesson. Okay, that's it for today. Bye bye.
Maybe
Bye bye.
3, 4 digits.
Bye bye.